Hello students, welcome to class of physics. In previous lecture, we discussed about the nucleus and the different terms associated with the nucleus. Okay, and when we discuss about the relation between mass and energy, that is one atomic mass unit equals to 931 MeV mega electron volt. Most of the students ask me how this can be written. Okay, so first let us clarify this in more details. Okay, so as we know, Albert Einstein's mass energy relation from the theory of relativity, E equals to mc square. Okay, from the theory of relativity we all know the relation E equals to mc square. Okay, this relation indicates that mass and energy both are convertible. That means we can convert mass into energy and energy into mass. Okay, so this relation is derived here. E equals to P square C square plus m naught square C4 root over. Okay, if we consider a high speed moving particle, that is photon. Okay, for photon the velocity of photon is equal to the velocity of light. Okay, and since the photon always possesses its motion, then we can say its rest mass. Okay, rest mass m naught equals to 0. Okay, because photon always in the state of motion. Okay, so its rest mass becomes 0. So we can write E equals to P square C square root over. Okay, so simply we can have E equals to Pc. Okay, where P is the momentum of photon. Okay, since photon moves with the velocity of light, so we can say momentum of photon P equal to mass into velocity of light. P equals to simply mv, but here v is the velocity and the velocity of photon is equal to the velocity of light. So simply we can replace v by velocity of light. Okay, so that implies to, here we can, if we substitute p by mc, so mc into c. Okay, so E naught equals to mc square. Okay, so that is mass is converted to energy and energy can be converted into mass. Okay, so let us find this relation. Okay, suppose here we want to convert mass of one atomic mass unit in terms of energy. Okay, suppose one atomic mass unit, as you know, one atomic mass unit equals to 1.66 into 10 to the power minus 27 kg and velocity of light equals to 3 into 10 to the power 8 meter per second. Okay, and we know the relation, that is 1 joule equals to, or simply 1 electron volt. Okay, we have already proved in the previous class, 1 electron volt equal to 1.6 into 10 to the minus 19 joule. Okay, so if we substitute here the mass by mass of one atomic mass unit, okay, then we find E equals to, that is mass of one atomic mass unit 1.66 into 10 to the power minus 27 into c, that is the velocity of light, 3 into 10 to the power 8, that is square in terms of joule. Okay, so if you convert joule in terms of electron volt, what we get? E equal to 1.66 into 10 to the power minus 27 into 3 into 10 to the power 8 square divided by 1.6 into 10 to the power minus 19, and the unit here electron volt, because 1 joule is 1 by 1.6 into 10 to the minus 19 electron volt. Okay, so if we calculate this, so that will give E equals to 931 mega electron volt. Okay, I already take the conversion. Okay, so 931 electron volt. So energy of one atomic mass unit. Okay, energy obtained from the mass of one atomic mass unit is 931 mega electron volt. Clear? Okay. So now discuss about characteristics of nucleus. Okay, so what are the different characteristics we study? First thing, that is the radius of the nucleus. Second thing, size of nucleus. Okay, third thing, that is the nuclear density. Okay, fourth thing, that is nuclear charge. Okay, and fifth, that is nuclear mass. So these are the different characteristics that we discuss in this class. Okay, so when we discuss first about the radius of nucleus. Okay, suppose we take the radius of nucleus as r. Okay, so from the very beginning we discuss the nucleus consists of protons and neutrons, and combined proton and neutrons are called nucleons. Okay, as we move higher towards the periodic table, the number of nucleons gradually increases. Okay, or simply we can say the atomic number of the nucleus gradually increases from hydrogen, helium, lithium, beryllium towards the higher of the periodic table. Okay, so we can say the number of or the atomic number of the nucleus gradually increases as we move higher of the periodic table. Okay, then as the number of nucleons increases, then the size of the nucleus also increases with increase of atomic number. Okay, and when the size of the nucleus increases, then we can say the radius of the nucleus also gradually increases. That means the radius of hydrogen is not equal to radius of nitrogen or radius of iron or radius of any other elements. Okay, so how can we find radius of one element? Okay, so the radius of one element or radius of any element is obtained from the relation r equals to r naught a upon 1 by 3. Okay, where r naught is a constant. R naught is a constant. R naught is a constant, and its value is 1.2 Fermi or 1.2 into 10 to the power minus 15 meter. Okay, so let us prove this relation. How can one derive R equal to R naught a to the power 1 by 3? Okay, A, that is the atomic mass number. Atomic mass number. Okay, so let us derive this relation. Okay, this relation can be derived from the nuclear density. Okay, as we know, density equals to mass divided by volume. Okay, density of any substance, that is mass by volume. So simply we can write density symbol, that is rho, equals to mass by volume. Okay, and the mass of the nucleus depends upon the atomic mass number. Okay, and if we write here rho equals to 1 point, that is the total mass of the nucleus is atomic mass times mass of one nucleon. Okay, either you may take mass of proton or you can take mass of neutron. Okay, suppose I take here, because mass of proton and mass of neutron, they are nearly equal. Okay, so 1.67 into 10 to the power minus 27 into A. Okay, that is the mass of either proton or neutron, and that is the total number of protons or neutrons inside the nucleus divided by, if we consider r is the radius of the nucleus, then everyone know volume formula, that is 4 by 3 pi r cube. Okay, but what we want to calculate, we want to calculate this r, radius of the nucleus. Okay, so this can be written r cube equals to 1.67 into 10 to the power minus 27 times a divided by 4 by 3 by rho. Okay, so that implies to r equals to 1.67 into 10 to the power minus 27 divided by 4 by 3 pi rho times 1 by 3 into a upon 1 by 3. Okay, so if you take the cube root in both sides, okay, so what we find, if we take this term as any constant, okay, so if we replace the total term is, okay, so if we replace this total term as any constant r naught, so where r naught is a constant and its value is nearly calculated 1.24. Okay, so we can find the relation r equal to r naught a to the power 1 by 3. Okay, clear? So the size of the nucleus will be determined by this formula. Okay, and here most important thing, the size of the nucleus depends upon the atomic mass number. Okay, and we can say that there is a direct variation. That means when atomic number increases, then radius also increases. Okay, so the radius of the nucleus gradually increases as we move higher in the periodic table. That means when the atomic number increases, then size of the nucleus also increases. Okay, clear? Second thing, we discuss about the size of the nucleus. Okay, so when we take the discussion of size of the nucleus, then what we find, the size of the nucleus depends upon the atomic number. Okay, so that will, second thing, that is the size of the nucleus, or simply we can say that is the volume of the nucleus. Okay, so as we know, volume of the nucleus equals to 4 by 3 pi r cube. Okay, and volume V equals to, if you substitute here, r equals to r naught a upon 1 by 3. Okay, then what should be the volume? So volume V equals to 4 by 3 pi r naught a upon 1 by 3 whole power 3. Okay, so that will give V, that is the volume, equal to 4 by 3 by r naught cube a. Okay, so this term is a constant. So what do we find? V proportional to a. V proportional to a. What does it means? This means when the atomic number increases, then volume of the nucleus also increases. That means the nuclear size depends upon the atomic mass number a. Okay, the nuclear size of the nucleus depends upon the atomic mass number, and the volume of the nucleus increases with increase of atomic mass number. Okay, third thing, that is the nuclear density. Okay, so when we discuss about the nuclear density, what we find? Nuclear density. Okay, so nuclear density, simply we know the density is mass upon volume. Okay, so when we find the mass of the nucleus, that is density, that is mass divided by volume. Okay, so the mass of the nucleus, what is the mass of the nucleus? As we discuss, earlier the mass of the nucleus depends upon the atomic mass number times mass of either nucleus. Okay, so that is 1.67 into the minus 27 times A divided by volume of the nucleus, that is 4 by 3 pi r cube. Okay, r, that is the radius, that is r naught A upon 1 by 3. So that will give 1.67 into 10 to the power minus 27 times A divided by 4 by 3 pi r naught A upon 1 by 3 whole power 3. Okay, so if we solve this term, what do we find? So we find 1.67 into 10 to the power minus 27 times A divided by 4 by 3 pi r naught cube A. Okay, so this term A and A cancels each other. So what do we get? 1.67 into minus 27 divided by 4 by 3 pi r naught cube. Okay, r naught, that is 1.2 for me. And if we solve this expression, then we find the radial density of the nucleus will be 2.3 into 10 to the power 7 kg per meter cube. Okay, so that will give the density of the nucleus. Okay, and the main thing in the density of nucleus is the density of nucleus is independent of A. Okay, there is no dependence of atomic mass number on the nucleus. Okay, so the independent quantity of atomic mass number indicates that the density of the nucleus remains constant from nuclei to nuclei. Okay, so what is the value of density? That is rho equals to 2.3 to 10 to the power 17 kg per meter cube. Okay, clear? Fourth thing, that is nuclear charge. Next, come to nuclear charge. Okay, so number 4, that is nuclear charge. Suppose I consider here Q. Okay, as we discussed, inside the nucleus there are two main particles exist. One is proton, another one is neutron. Okay, neutron is a neutral particle and proton possess positive charge. Okay, and we can say the total charge of the nucleus is only due to the protons only. Okay, so the charge of the nucleus always due to protons. Okay, and if I consider the total number of protons inside the nucleus is Z, that is atomic number. Okay, so and E equals to charge of one proton. Okay, so the total charge of the nucleus always positive because all the protons possess positive charge, and Q equals to Z upon E. Okay, so that will give the charge of the nucleus, or simply we can say nuclear charge. Nuclear charge is positive and it is only due to the number of protons inside the nucleus. Okay, and this formula already we have discussed in electrostatic, that is Q equals to Ne. Okay, similar formula in the nucleus. Okay, last thing, that is nuclear mass. Okay, very important. Inside the nucleus there are protons and neutrons. Okay, both proton and neutron possess some mass, and mass of the proton and neutrons are nearly equal. Okay, and we can say the mass of the nucleus is due to both protons and neutrons. Okay, so mass of the nucleus depends upon the atomic mass number, that is A. Okay, and when we observe, let us take one example. Suppose that is nucleus. Okay, inside nucleus there are protons and Okay, and proton and neutrons both possess mass. Okay, suppose I take one example. The number of proton is 10 and number of neutron is also 10. Okay, so total number of nucleon inside the nucleus is 20. Okay, but the total mass, as we measure in a mass spectrometer, that is a device that is used to measure the mass of the nucleus. Okay, let us take an example. The total mass of the nucleus contained in the total number of nucleons inside the nucleus is 20, but the mass spectrometer measure the mass of the nucleus as 18. Okay, so there is a difference. This is the measured mass and this is the actual. Why there is a difference? There is a difference of 2 units. Why? Okay, that means we can say the actual mass of the nucleus is not equal to the measured mass of the nucleus. There is always a difference between actual mass and the observed mass. Okay, and that difference in mass we name as mass defect. Okay, we discuss in later. Okay, so there will be the change of mass between the number of total number of atomic nucleons and the observed mass of the nucleus. Okay, so when we measure the mass of the nucleus is, suppose that is the measured mass, observed mass that equals to capital M, that is measured through a mass spectrometer. Okay, and mass of proton that equals to MP, mass of neutron that equals to Mn, and when we measure the observed mass equals to, okay, and the variation, the observed mass with, suppose there will be the Z number of protons, that is ZMP, plus N number of neutrons. Okay, N can be written as A minus Z number of neutrons. Then what we find? There is always a variation between, that is the actual mass, that is the observed mass. Okay, the observed mass and actual mass is not equal. Okay, and that loss of mass is known as mass defect. Okay, and we find the actual mass of the nucleus is always greater than the observed mass. Okay, the actual mass of the nucleus, here we can write the symbol less than. That actual mass of the nucleus always greater than the observed mass of the nucleus, and that variation in mass is called mass defect. Okay, so the mass of the nucleus depends upon mass of proton and mass of neutron. Okay, so mass of proton and mass of neutron constitute total mass of the nucleus, but when we measure the mass of the nucleus in a mass spectrometer, then we find the actual mass of the nucleus is greater than that of the observed mass. Okay, so there is a difference between actual mass and observed mass, and that difference in mass is called mass defect. Okay, and simply we denote mass defect at change of mass, delta M. Delta M, that is a small change in mass, so we can say actual mass is greater, so that is ZMP plus A minus Z Mn minus the observed mass, that is capital M. Okay, we discuss it. Understand? Okay, so what we get? Nuclear radius, size of the nucleus, density, charge and mass. Okay, radius, that is R equals to R naught A upon 1 by 3. R naught, that is the radius, that is the constant 1.2 Fermi. Size of the nucleus, that is V proportional to A. Volume of the nucleus increases with increase of atomic number. Nuclear density rho equals to 2.3 into 10 to the power 17 kg per meter cube, that is independent of atomic mass number. The nuclear charge depends upon the total number of protons inside the nucleus, and nuclear mass The total mass of the nucleus depends upon the mass of the nucleons. Okay, that is the number of protons and number of neutrons. And we find the actual mass is always greater than that of the measured mass. And mass is measured by an instrument that is called mass spectrometer. Okay, clear? So in next class we will discuss about the nuclear force and the mass defect, binding energy, like this. Okay, thank you.